Hello everyone and welcome to our yet another discussion on linear programming simplex method. In this segment we are going to look at the linear programming model, what I may say the LP model. So I assume that you have the question, you have read through the question, though we are going to read it through together again. Okay, saying that steel rolling mills makes doors and windows. Each door requires 10 hours of machine A and 20 hours of machine B. Each window requires 30 hours of machine A and 10 hours of machine B. The company has a maximum of 90 hours available on machine A and a maximum of 80 hours available on machine B. The company derives a profit of 36,000 on each door and 72,000 on each window. If we let X and Y represent the number of doors and the number of windows respectively, the very first thing you need to do is to formulate the linear programming model for the above information. So this one I have no doubt that you can all do it. Okay, I have no doubt that you can all do it. So we shall go straight into the linear programming model. But the first thing we do is to put the decision variable. Okay, is to put the decision variables. What are our decision variables? So the items that we are looking at, we have the doors and the windows. Okay, they're making doors and windows. So if a door is represented by X, windows is represented by Y, we are told that on machine A, the door needs 10 hours, the window needs 30 hours. But the number of hours we have on the machine A, a total of 90 hours. When it comes to machine B, a door needs 20 full hours, 20 hours. Whereas the window, when the window comes in, it needs about 10 hours to get done on machine B. In total, we have 80 hours of machine B. Again, from the information given, we are told that in terms of profits, one single door brings us 36,000 in profits, and then one single window brings us 72,000 in profits. What is our goal? Our goal is to maximize our profit, maximize profit Z. So we want Z as big as possible. So here I'm saying that let's let Z be the total profits. Z are the total profits. So this is what you're supposed to do, especially if the examiner has given you a scenario kind of question whereby you have to derive the figures from the information. So I'm going to give you 5 minutes. You put down this table, then we continue to write our linear programming model. All right, now let's go into the linear programming model. I told you this is like a computer code. Okay, so you don't just write the model anyhow. Step 1 of the simplex method requires that the linear programming should be expressed into the standard format. Step 1 of the simplex method requires that the linear programming should be expressed into the standard format. That was our step number 1. This is what is known as the linear programming model. So it is not different from the one we saw when we are doing a graphical method. It is the same. So we begin by writing the objective function. We begin by writing the objective function just like this, which is to maximize the profit Z equal to 36,000 X plus 72,000 Y. This is subject to the constraints, including the machine A hours, that's 10x plus 30y less equal to 90 hours. Machine B, another constraint, which is 20x plus 10y less equal to 80. And then don't forget the non-negatives. Non-negativity, because we don't expect to have any negative doors and windows. Okay, that won't be realistic. So x greater equal to 0, y greater equal to 0. So x being the doors, we don't expect to produce negative doors. Y being the windows, we don't expect to produce negative windows. So that's why we have the non-negativity in the model. So you're going to write this model in the next 2 minutes, and then we continue. Next, we are going to go through the initial tableau. So I want you to go to the next lecture discussion, which is our lecture number 3 under Simplex, where we are going to discuss the setting up of the initial tableau. Thank you.